Hey everyone, welcome back to CIS 17A. Today we're going to be covering lesson number 15 on classes, part 1. So for this section, I'm just going to have you guys do a little bit of reading, and unlike most of the other assignments, you're not going to be writing a program. You're going to be answering some questions, 13.1 through 13.5 from the textbook, and that comes right after page 727, as we'll see in just a little bit. And just like with the lesson that we did on pointers part 1, where I had you submit a Word document or a text document with your answers to the questions, you'll do the same thing for this assignment as well. So you will not be writing a program for today's assignment. You will just be answering the questions from the textbook. All right, so introduction to classes. So today's lesson represents a huge shift in the way you think about writing programs. What you've been doing up to this point is writing what are called procedural programs. The focus on procedural programs is on declaring variables inside your main function and then writing functions outside of main that accomplish specific tasks. Now, that's okay for small programs, but when you start to scale up and start to try to write larger applications or more complicated applications, procedural programming can become very error-prone and buggy in terms of the code. Thus, the shift to C from C to C++, and the shift towards what is called object-oriented programming. So, what is object-oriented programming? So, think of something like a rectangle. And this is the example that the book runs with and the example that I'll show you in the programming example later on. So when we think of a rectangle as an object, we need to think about what defines a rectangle. So a rectangle has a width, a rectangle has a length. Now if we were going to implement a rectangle object in programming code, we would need to do certain things, like we would need to set the data. We would need to be able to assign a value to the to the width and to the length. We would potentially need to be able to display just the width or potentially display just the length. And then we might need to do something more fancy like display the area. So the area of a rectangle is the length times the width. So the idea is that with object-oriented programming, you want to sort of hide this information from the user. We don't want the user to be able to directly modify the width or the length. We want them to indirectly be able to modify the width or the length because we want some sort of process by which we can validate when the user tries to specify what the width is, what it is. We want same thing with the length. We want to be able to error check and see that they're providing a valid value for that property. All right, so there's a lot of text in here, and it is good for you to go and read through it to get a very in-depth understanding of what's going on. But this is rather long, and rather than me just reading the book to you guys, I'm going to go ahead and just kind of skip through and leave it up to you to read through this. I will highlight certain things like this, that the attributes is what we refer to these as. So any variables associated with a class are referred to as attributes. And then member functions. Those are the things down here that are going to allow us to potentially modify or retrieve information about the class. So we call those attributes and member functions. All right. So that's kind of how you can think of an object. You can just think of it as a collection. It's a collection of variables that we call attributes, and it's a collection of these little circles or functions that manipulate the data or retrieve the data. That's it. Just want that to kind of sink in for a second. That's all classes are. They're just a collection of variables and functions. So for as much text and dialogue that you're going to see that is going to come up ahead here, try to hold on to that idea. And that really kind of reins in the complexity of understanding what object-oriented programming is. Classes are just collections of variables and functions. That's it. All right. And then it mentions here that the term methods is also used in terms of, or in exchange for member function. So if I say member function or method, I'm saying the same thing. All right. Okay, so an object encapsulates data and functions, and then for somebody who wants to use the class, they have to do that via these little circles or functions. Okay, so there's no direct access outside of the class to that data. All right. One way to think of this is, and the reason why we do this, and I mentioned earlier that it simplifies programming when you're working on large-scale programs, is to think of it like cars. When you drive your car, there's all kinds of things that are happening. But the way that we interact with our car is very limited. We have an ignition switch that we use to turn the car on. We have a steering wheel that we use to go left or right. We have a gas pedal to accelerate, brake pedal to slow down. And you guys don't have to shift gears anymore. That was back when I was in high school. So anyways, the idea is that we only have 1, 2, 3, 4 things here that we really need to interact with to drive a car. So this greatly simplifies the process of controlling a vehicle, and it allows you to control other vehicles, even though they're not the same. If you learn how to drive a car, you can learn how to drive a truck, and so on and so forth. So that's the idea behind object-oriented programming. Think of these functions as like the steering wheel, the gas, the brake, right? So that's all you got to interact with. Now, we know behind the scenes that, let's say this is the steering wheel for my car, that when I steer left, if you lift up the hood and you look underneath, there's all kinds of stuff that's happening when I steer left. There's all kinds of interactions and things pushing against one another, so on and so forth. When I push on the gas pedal, let's say this is the gas pedal, I push down the gas pedal. Again, a whole series of events happens under the hood of my car. Now the idea is that I don't need to know how those things work. When I push down on the gas pedal, I don't need to know what's happening in my engine that's making my car accelerate. I just need to know, push on the gas pedal, my car goes faster. That's, again, the idea behind object-oriented programming, is by hiding all this information from the user, it simplifies the process of using complex objects. Now, the other thing is by limiting code to only interacting with functions, it prevents us from breaking things. Imagine that I push down the gas pedal and I got to get out of my car and I got to open up my hood and I got to start pushing and pressing on different components of my engine in order to get it to work. Well, now, obviously you don't want to get out of your car while it's accelerating and opening your hood. But let's say for fun's sake that this is Mad Max and we're going to go ahead and do that. We're going to hop out, we're going to open up our hood, and we're going to start pushing and pulling on things inside the engine. What's going to happen? Probably we're going to break the engine because we don't know what any of that stuff does. All right, so that's the idea, again, is that we're simplifying the process of interacting with things, and we're preventing the user from breaking the object by hiding the variables or data associated with a function. All right, so that's basically what this is describing here. Reusability, again, if I learn how to drive one car, I can learn how to drive other types of cars, even though they're not the exact same thing. Classes and objects. All right, so a class you want to think of as like a blueprint. So a class is vague or arbitrary. It does sort of define some things, like with our example with the rectangle. With our example with the rectangle, we know that it's going to have a length and a width. But it's still somewhat arbitrary because we don't have an exact number for the width. We just know that it has a width. We know it has a length, but we don't know what those values actually are. So that's the idea behind a class versus an object. So the class specifies the different variables. An object represents a specific instance of that class. So an object is specific. So for example, if I said a box has a length and a width, that's arbitrary. I'm just describing the class. But if I say my box has a width of 5 and a length of 10, that's a specific instance or an object of the class. All right, so that's what this is trying to describe here. So think of a class as like a blueprint. In this case, this is a blueprint that describes a house, and then using that blueprint, we can make several instances of houses. Now here, it's showing these all as exactly the same. A better example would be to show this house has one window, this house has two windows, this house has three windows, to show that just like with the rectangle example, the width and the length are going to be different depending on the specific instance of the class, right? So in this case, this is just an example of three things that are exactly the same. So then here we get an example of a class called insect. We know there are lots of different types of insects, but we can declare a more specific instance of an insect like a housefly. And what are the properties that describe a housefly? We could declare an instance of an insect class called mosquito. And what are the specific things about a mosquito that make it different from a housefly? So in this case, insect is the class, housefly is the object, and mosquito is the object, right? So insect is like the blueprint, housefly and mosquito are like the instances where we get more specific about what is the difference between those two different insects. Okay, so this is just saying the same thing that I just described. So insect is the class, these two things are the object. All right, moving on. So here, they're just showing you, again, the idea of the rectangle. Everything's being encapsulated with width and length being the variables that describe a rectangle, and these are the different member functions that we'll use to modify or get information about a rectangle. All right, next the book is going to go ahead and describe some features of a class that you may have already worked with. We haven't actually done a lot of stuff with strings in this class. We actually did more with vectors than we did with strings. So we can kind of substitute string with vector here, and it probably will make this section make more sense. But a string is an object, or I'm sorry, a string is a class. Here, we're declaring a specific instance of a string, city name. So again, string is somewhat arbitrary. City name is more specific. This is a city that we are trying to describe. So Charleston is a city. We can assign that to the city name, and then we can use the member functions of the class to get information about it. So for example, we can use the length member function to figure out how many characters are in the string, in this case 10. Now this is similar to when we use vectors. So with vectors, we could use the dot operator to access the member functions of vector classes, and we use things like size. So remember, we used vectors with a for loop, and we use size to determine how many members, or I'm sorry, how many elements of the vector there were. We also used the dot push back member function to add things to an empty vector. So those were both examples of classes. Okay, so what is the syntax that we actually use to describe a class? Okay, so I could just read through all this stuff here to explain to you guys what's going on. They're again using the example of a rectangle for all these examples, but instead I'm just going to go ahead and code it so you can see. All right, to define a class, you use the word class. Next, you're going to put the name of the class, and I'll go ahead and stick with the book and use the example that it gives of a rectangle. I'll call it rect. Notice that we use a capital letter when we define the class name. We're going to put some curly braces, and always remember to include a semicolon at the end. So we know that a class is a collection of variables and member functions. And we know that the variables are the little nitty-gritty details behind the scenes that we don't want people to play with or mess with, so we want to make those private. And then put a colon. So when we put the word private, we're going to then follow with all of the stuff that people should not be able to directly change. So in this case, it's going to be the length of the rectangle and the width of the rectangle. All right, so those are the only things that we need to describe a rectangle. Next, we need some method by which people can access this information to either change it or retrieve it. And that would all be stuff that is considered public. Next, we're going to list all the functions or member functions or methods, whichever term you'd like to use, to either get or set those variables. So what we're essentially going to put here is a function prototype. All right. So let's say that we're going to set the stuff. So in that case, we're not returning anything. So we'll call that set length. And we're going to have to pass that an integer. Just like with any prototype, you put the return type, you put the name of the function, and then you put the parameter list. And just like with prototypes, you don't have to provide a name. All right, so think of that like a prototype. All right, next we're going to go ahead and provide a way of modifying the width. And we're going to provide a way of getting the width and the length. So we'll say get length. We don't need to pass that anything. And then get the width. We don't need to pass that anything because it's retrieving this information up here. Now, here's something a little different. Since these are not modifying the attributes of the class, we want to make this const. So by putting the word const here, it means that whatever code we eventually write for these methods, that if we try to modify those variables length and width, we'll get a compiler error. So it's always good to use the const keyword if the member function does not modify the values of the class. And then we'll put one more down here called getArea. That will give us the area of the class. Oh, I'm sorry, the area of the rectangle. So there you go. That's how you write the blueprint or class declaration for something. All right. We make all the attributes or variables private. We make all the member functions that we use to modify things public. Now it is possible to make stuff, make functions that are private, but for now I don't want to complicate things more than I need to. Now the book also mentions that you can kind of mix and match things. You don't have to put private first. You can put public first. You can also mix. You can put this, and then I can go down here and I can put private and declare more private stuff. But even though it's again one of those things that, yeah, you can do it, but should you do it? No, you should not mix private and public back and forth. And then should you put public stuff first? No. You can do it, but nobody does that. The convention is that you always put private stuff first, and then you put public stuff next. It's also worth mentioning that if you don't put the word private, that anything you declare is by default considered private in a class. Now, I also want to mention that the book constantly refers back to something called a structure. Anytime the book refers to something called a structure, we have not talked about those in this classes. The book is kind of old. Structures aren't used anymore, but a structure is just like a class. The only major difference is that with a structure, everything is considered public instead of everything by default being private. All right. But again, don't worry about that. I'm not going to ask about anything about structures on a test or anything like that. So if you see the word structure and you're just confused about it, just gloss over it. Don't worry about it. Okay, so there's our blueprint. There's our class declaration. The next thing we would need to do is define all these functions. So I'm going to go ahead and just copy and paste these down here. And then we're going to get a lot of compiler errors because stuff is not defined yet. So I'm going to go ahead and just copy these and paste them after these, and I'll do some cleanup here. All right. Okay. Okay. All right. Now, if I leave these like they are here, let's do a little more cleanup. All right. So if I leave these as they are now, there's no way for the compiler to know that these are associated with my class. Just because this function has the name setLength, and because I have a setLength member function defined inside of a class, the compiler has no way of knowing that these are actually connected to each other. So what we have to do is use something called the scope resolution operator, which looks like that, 2 colons. And what you do is you bind this function to the class by putting the name of the class in front of it. So I'm going to go ahead and copy that and put that here. So by putting the name of the class, the scope resolution operator, followed by the name of the member function, the compiler now knows that this function definition is for this member function. Okay, so that's a common mistake for people to forget to put the name of the class followed by the scope resolution operator. So I'm going to go ahead and just copy and paste that into all these functions so that it knows, that these are associated with that class. Okay. Also notice that the word const has to appear here as well. That's different than regular functions. All right, so a lot of code here to do something as simple as describe something like a rectangle. And I'll explain why it's worth going through the trouble in just a little bit. Okay, so we have our functions that set or modify. We have our functions that get. So let's go ahead and start defining these. So let's call this the length, and let's call this the width, because even though we can omit a name in the prototype, we can't omit the name in the definition. And then here we'll simply say that my length is equal to L. So when the user calls this method setLength, it's going to pass, the user will also pass in that value, and that will initialize the length value. Down here for width, we say that the width is equal to W. Now, I'm going to go ahead and get ahead of myself a little bit before we get into the other methods down here. To get, I'm going to go ahead and define an instance of my rectangle. Now to define the instance of the rectangle, I put the name of the class followed by the name of the instance. So we'll just call this box. So the class name serves as the placeholder for what we would normally put for the type, like int or float or char. That's where we put the class name. And then I can say that I want to set the box's length by putting the dot operator, just like we did for vectors when we use like the size or the push back member functions. So I can say box.set length, and then here I would have to pass in some value. So I would have to ask the user for that value. And then read that in. Here. All right, and then pass that into the member function. Okay, so what have we done? We declared an instance of a rectangle called box. We made a variable to temporarily hold the length provided by the user, and then we called setLength and passed it that value. We could do the same thing to set the width of the box. So let's go ahead and just change this to width. All right, there we go. All right, so this is going to go ahead and initialize the values of those variables. Now you may be saying to yourself, and rightfully so if you've never done object-oriented programming, this seems like a lot of work just to set 2 variables. Right? Like we could just go down here to main, say int length, int width, and do stuff with those values. And I would agree with you completely, if everything was as trivial as a rectangle with only 2 attributes. But again, remember, we're talking about advanced programming. We're talking about complex objects like a car. You know, it has thousands of variables in it. And again, we don't want the user to be able to just directly modify those things. So let's go back up here to our set function. Now the book just does this. It just shows you, hey, this is how you can this is how you can initialize the length and the width using these set functions. And the book calls these mutators, by the way. So they call mutators are member functions that modify attributes of a class, and accessors are things that get the values from a class. So accessors and mutators. This would be a mutator. So here's what the book doesn't show you, is that the class now has the ability to validate what you're doing. So I can say things like this. I can say if the L is greater than 0, length is equal to 1. So it's doing a little error checking. So I can't have a rectangle with a negative surface area, right? So this is and this is a very trivial example of error checking. We can do a lot more than this, and we could also, like, return a value. We could do all kinds of stuff. But the point is we can do whatever we want. We can put whatever code we want or need in here to validate the data being provided to initialize this class is valid, and the way that the user is trying to manipulate the class is valid. That is the major strength of classes and why it's worth going through all this trouble. Well, it's just part of the reason why it's worth going through all the trouble to write all this extra code just to do something like set the length and the width of the class. All right, so let's go ahead and finish off these functions down here. Get length, we're going to return the length. Get the width, we're going to return the width. So we're just retrieving what those values are from the class. Oops. And then down here, we're going to get really fancy, you guys. Check this out. We're going to return the length times the width. Not the width, the width. Fancy, fancy, fancy. But again, you can imagine that, like, if this was a car class and this was like accelerate, there'd be tons of code in here, right? We'd be doing all kinds of different stuff here to make the car accelerate. All right. So then down here, as a last step, we'll go ahead and just see out the width. No, I'm sorry, the area, not the width. Okay, and then we can just put box dot get area and an inline. All right, so there we go, you guys. There's our fancy pants rectangle class. And let's go ahead and run it. All right, let's make this a 3 by 5 box with an area of 15, 3 times 5. So there you go. There's how you can implement a class of a rectangle. All right, now the book is going to basically go through everything I just showed you guys. So that's all that's going on here. And again, notice that it's not doing any kind of error checking. It's just the set width function is just going to go ahead and take W and just initialize that. But later you'll see that it'd be better to do error checking. There's our area function. Here it's just saying that this is the generic format for defining a class. You put the return type, the name of the class, the scope resolution operator, the name of the class, and then the parameter list, just like we've done before. Here they just show you what not to do. Okay, sure, yeah, don't do that. Don't put code that's not valid. Like I mentioned, functions that get stuff are called accessors. Functions that modify the variables or attributes of a class are called mutators, also called set and get functions. Here it's just mentioning you should use the word const if it's a method or class, I'm sorry, a method or member function that is not going to modify data members. And then let's see, the importance of hiding data. Yeah, like I said, you don't want to get out of your car and open up the hood and start poking and prodding stuff if you don't need to know what it does in the engine of your car. an instance of a class. This is what I just showed you. So here you're going to put the name of the class, then you're going to put the name of the instance, like we did for my example, rectangle and box. So this is the class name, that's the object name. Okay. Here we're using get and set functions. Notice we use the dot operator, just like we did in vectors and in the demonstration that I just gave you. And then here they're going to demonstrate what I just wrote. So I'm going to go ahead and just skip past that because that's exactly what you just saw me do on my own. And again, it's a lot of code just to do something as simple, but you'll be grateful later on in your career when you understand how to create classes. All right, this is mentioning that when you declare an instance of a class, if you don't have initializers, that the values of the attributes will be garbage. So in other words, if when I do this, the value of the value of length and width are garbage after this line of code executes. So if I was to call get length or get width after I did this, or if I was to call get area, it's just going to be a random number. It's going to be garbage because I didn't initialize them. We'll see how to do that later on. You can provide default arguments to it. Okay, let's see. Here, they're just declaring a different instance of a rectangle instead of a box. We're saying, hey, this is a house. And a house is composed of a kitchen, a bedroom, and a den. And then we can call the member functions set length and set width to say how big is the kitchen, how big is the bedroom, how big is the den. And then we can get the total area of the house by just adding up these values. Just an arbitrary example that the book is giving you, nothing special about that. Okay, so you can see the run here. Getting the length and the width of the kitchen, the bedroom, the den, and then the total area of the house. That's a tiny house, man. 920 square feet. Times are tough. All right. Let's see. So they're just doing all that. Stale data. Don't worry about it. Pointers to objects. Okay. So this is the last thing we'll talk about. So you can make a pointer to an object just like you can create a pointer to anything else. And again, I'm just going to go ahead and walk you through how you would do that. So one way we could do that is by using the new operator to dynamically allocate it. So I could do something like this. I could say rect box and then say something like rect box, star box underscore pointer is equal to the address of box. Okay, and that's totally fine. So now I have a pointer that points to box, and then I could use box PTR to initialize stuff. So I could take this, and I could use that instead. However, as you see the red squiggly lines indicate, when you use a pointer to call method functions, you don't use the dot operator. You use something called the arrow operator, which looks like that. Okay. Now I'm going to go ahead and replace all this stuff. So let's do box PTR with the arrow instead, and then box PTR with the arrow. Okay. So there you go. So that's the only difference is if you're going to make a pointer to a box, it's the same rule. You use the address operator to get the address of the instance of it. And then you use the arrow operator instead of the dot operator. Just so we can see that this works, let's run it. And it should do the exact same thing as it did just a second ago. It wants to know what is the length. Let's make this 5. What is the width? 2. And the area is going to be 10. So there you go. So that's very easy to use pointers to objects or pointers to objects. All right, you can also dynamically allocate this as well. So I could do something like this. I could say goodbye box, you don't exist anymore. And I could say that this is now equal to a new rectangle. So I can dynamically allocate it like that, and it will do the same thing. But remember, anytime you use the word new to dynamically allocate something, you need to do what? What do you need to do? How many of you said it right? Yes, you need to delete it. So I need to delete anything that I dynamically allocate, like so. All right, so I could also use a pointer to a class or pointer to an object just like this. And again, this will just do the exact same thing as we saw a moment ago. Let's make it 6 by 3,689. Blah. Large box. All right, so it does the exact same thing that we saw just a moment ago. Okay, you guys, that is it for all the new material on classes. As I mentioned, there are some questions in here that you'll need to answer for today. So this is all just going over pointers with classes, everything I just showed you. So here you can see this is the same example as above, just using the arrow operators and pointers and dynamic memory allocation instead, just like I just showed you. And here are your lab questions. All right, so just like before, just put your name at the top of a Word document or a text document, notepad document, and just answer these questions. There's not a whole lot. There's only, what, 1, 2, 3, 4, 5. And then just go ahead and upload those. And that's all you got to do for the lab for today. Okay? All right, hopefully that makes sense to you guys. I do encourage you, even though you don't have to write any code, I do encourage you to go through and write down the code that I just demonstrated here, just so you can see and familiarize yourself with how to write down the code for declaring a class, because for the rest of the semester we're going to be using classes a lot. All right, and you do want to get really comfortable and familiar with the syntax for declaring classes. So that's it for today. I hope you guys are doing well. As usual, just let me know if you have any trouble with anything. Send me an email and I'll do my best to help you out. All right, I will talk to you guys again soon.